By the end of this video, you will be able to explain what relative time or relative age means, geologically speaking. You'll be able to list and describe the various principles of relative time or age and how they are applied to determine the geologic history of an area. And you'll be able to relate or connect the examples of the demonstrated model to the various relative time principles.
All right, so in teaching geologic time, we talk about the principles of relative age, which you probably learned.
Yep.
Andrew and Erica, you learned in your introductory geology classes, and as geology majors, you've probably talked even more about them. But when we're talking about relative age, we want to use some sort of analog or analogy that makes it easy to understand all those different principles. Well, making a sandwich, we can get all those principles in just by making a simple peanut butter and jelly sandwich, 2 pieces of bread and peanut butter and jelly. So when we make a peanut butter and jelly sandwich, we usually start out, we put the bread on the table, right? And we get some peanut butter. So I'm going to ask Andrew and Erica to also make this peanut butter and jelly sandwich. And we take the first piece of bread and we spread the peanut butter on top of it so that it completely coats the entire piece of bread, all the way spread out right to the edge. What do you notice about this peanut butter, Erica? What does it have in it?
It has peanut chunks in it.
It does have peanut chunks in it, right? Okay, and that's fairly important for one of the principles that we're going to talk about today. So we have the peanut butter on top of the first piece of bread, and that would be like the principle of, which principle do you think that would be like, Andrew?
I think that would be superposition.
Superposition, right, exactly, because the peanut butter is superior to or on top of the first piece of bread. So now we're going to take our second piece, our second spread, get some jam, and we're going to spread that on top of the peanut butter. And it's kind of hard to spread jam like this evenly, don't you find that, Erica?
Yeah.
And oh dear, you know, I'm just mixing this all up. The peanut butter is getting mixed in with the jelly. You know, that's kind of important too, because that's like the principle of inclusions, where the peanut butter had to be there in order to get included into the jelly. Did your peanut butter get included into your jelly? Yeah, it's hard not to mix it when you're making a peanut butter and jelly sandwich. But the jelly is on top of the peanut butter, so it's superposition. And now what's our last part? Last piece of bread to make our final layer. So superposition, bread, peanut butter, jam, bread. It's all superposition. We made this peanut butter and jelly sandwich while it was all flat. So that's the principle of original horizontality. Let's take a look at that jam again. What did you notice inside the jam, Andrew?
It has seeds.
It has seeds in it, that's right. Well, just like the peanut chunks in the peanut butter, the seeds in the jam represent fossils that are indicative to that particular layer. So that's like the principle of faunal succession. So we have superposition, original horizontality, faunal succession, and now we want to do what we should do if we're going to eat this. We're going to cut this sandwich. We're going to cut it in thirds. And Erica, in order to cut this sandwich, the sandwich had to be there for me to cut it, right?
Yep.
Yeah, so the knife cuts across this sandwich, all these layers. It's kind of like a fault or an intrusion of magma or lava through the rocks. So cross-cutting relationships, another principle that we can apply to making our peanut butter and jelly sandwich. So there we have our sandwich in thirds. Now let's rip apart that sandwich. We're going to take across that top layer of bread. Now imagine that some geologic time goes by and some erosion, weathering and erosion takes away some of this layer. We're kind of missing some of the rocks here. But we still know that the rock or the bread on both sides of our huge valley or canyon is the same on both sides, as is the jelly, as is the peanut butter. That would be like the law or principle of lateral continuity. Even though there's huge gaps of rock missing from erosion, we know that's still the same, especially because it has the same fossils, the same nuts, the same seeds in our jam. And, well, tell me about making a peanut butter and jelly sandwich. Do you pretty much make it the same way, like this?
Yeah, pretty much.
How about you, Andrew?
I think pretty much
the
everyone
same way.
does.
Everyone makes the peanut butter and jelly sandwich. They may cut it in triangles or rectangles, but we pretty much make the peanut butter and jelly sandwich the same way. Bread, peanut butter, jam, bread, we cut. That's like the principle of uniformitarianism. The principles that guide and govern geology today, whether it's waves breaking on the ocean, rivers meandering and weathering and eroding rock on its bank. What else?
I think another one could be volcanism, maybe?
Sure. And what's another one, do you think, Erica?
Earthquakes?
Sure. So all these different processes, glaciers covering and weathering and eroding the land and depositing sediment, all these processes which have been operating on, which operate on Earth today, have been operating in the past, geologic past Earth's history. Okay, so the next time you make a sandwich, whether it's peanut butter and jelly or bologna and cheese, think about the principles of relative age. I think it's time to eat.
When you have finished watching the video, you'll be taking a short questionnaire that will ask you to rate your confidence on a scale from 0 to 10 in performing all of the learning objectives, where 0 is not confident or sure you can do any of the objectives, 5 is fairly confident or sure you can do some of the objectives, and 10 is very confident or sure you can do all of the objectives.